Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know about angles for the upcoming test. So we are doing deductive geometry. We are looking at finding the size of angles without measuring them. We're just using deduction, mathematical logic to find what they are. So there are 4 types of angles on this slide that don't involve parallel lines, and then we need to know 3 types of angles involving parallel lines. So let's start with complementary angles. Note the spelling here. There's no I here, it's an E. It's not complement as in I give you a compliment, say something nice about you. It's complement as in goes together. So complementary angles form a right angle, because we know that a right angle is indicated by this symbol here is 90 degrees. So these 2 angles add up to 90 degrees. That's what complementary means. So x plus the 39 degree angle must add up to 90. We simply subtract 39 from both sides of this equation and we get x is 51. Make sure we include the degree symbol. So supplementary angles add to 180. Supplementary angles are what you get when a straight line is formed, because we know the angle of any straight line is 180 degrees. So this whole angle here is 180 degrees. So that means the angle marked x, the other angle marked x, and the 90 degree angle must add up to 180. So this question is a little more difficult than the previous. We're going to use what we know about equations. Luckily, we spent so long on equations earlier in the year. So we're going to collect like terms. X plus x is 2x. So 2x plus 90 equals 180. So we know that we have to undo what's been done to x in the opposite order to BIDMAS. We're going to subtract 90 from both sides and then divide each side by 2. So x must equal 45. Again, we make sure we put the degree sign. And that makes sense. These 2 angles are both marked with the same pronumeral, so they must be equal. They must add to 90 because 90 plus 90 is 180. So if you've got 2 numbers that add up to 90 and are equal, they must be 45. All right, angles at a point. So that's when you have a point here. Now the angle in a full revolution, full circle here is 360 degrees. So all of these 4 angles add up to 360 degrees. We'll note that 70 plus 40 plus 90 is 200. So whatever x is, when I add it to 200, the sum of the other 3 angles, I must get an answer of 360. So again, using our principles of an equation, I just subtract 200 from both sides. I get x equals 160. Make sure I put the degree sign. So vertically opposite angles are equal. Vertically opposite angles make an X shape. And I'll just go quickly through why that is. See, this angle and this angle here are supplementary. These 2 angles add to 180. So this angle here must be 80 degrees because the angles in a straight line are always 180. But hang on a minute. These 2 angles are supplementary. They make up a straight line. So the only way this can work is if x is also 100, because 100 plus 80 is 180. So x has to be 100 degrees, and even though the question didn't ask for it, this angle here would be 80 degrees. So vertically opposite angles are what you have when you have 2 lines or segments intersecting. They make this X shape. The ones opposite each other are equal. These 2 are equal, these 2 are equal. All right, let's now have a look at angles in parallel lines. So firstly, we need to understand what is meant by parallel lines. So 2 lines are parallel if they never meet. That means if they were to continue on forever and ever, they would never meet. So we indicate parallel lines with arrows like these. So these don't mean that the lines have equal length. These mean that these 2 lines are parallel. They would never meet. So this line here that cuts 2 parallel lines is called a transversal. So when you have a transversal, it creates co-interior, alternate, and corresponding angles. So we need to know what they are. So co-interior angles, co-interior means they're like both together on the inside of the parallel lines. So they are supplementary. That means they add to 180 degrees. degrees. They add to the angle of a straight line. So that means if this angle was, say, 120 degrees, this would have to be 60. If this angle here was 50, this would be 130. These two angles must add to 180 degrees. Now note, I've used different symbols for these angles because in general, they're not equal. Co-interior angles are usually not equal to each other. Now you can identify co-interior angles by a C shape like this, but it can also be a back to front C. So if I draw a back to front C here, these two angles here will also be equal. This one here and that one there. So these two angles add to 180, these two angles add to 180. On the other hand, alternate angles make a Z shape. So here we have two parallel lines and a transversal. Here, this Z shape, these two angles here, they are alternate, which means they must be equal. If this was, say, 100 degrees, so too this one must be 100 degrees. So that's why I've used the same symbol, same arc, to indicate both angles. They are actually equal in size. So just like for co-interior angles, the Z shape that this makes doesn't have to be like a normal Z. It could also be a back to front Z. So I could draw the Z like that, this angle here and this angle here. They would also be alternate, meaning they must be equal. So the last type of angles that you need to know for parallel lines are corresponding angles. They make an F shape. Once again, it can be a back to front F. So if I draw the F shape here, this angle here and this angle here would be corresponding. It turns out I can also draw an upside down F. So for example, this angle here and this angle here would be corresponding. So just like for alternate angles, corresponding angles are equal. If this angle here were, say, 60 degrees, this angle is 60 degrees. If this angle here was, say, 110 degrees, this angle here must be 110 degrees. So knowing these three types of angles will allow us to engage in deductive geometry. We'll be able to find the size of angles without measuring them. Now just note that these facts are only true when the lines are parallel. What do I mean by that? So co-interior angles add to 180 degrees only when the lines are parallel. Alternate angles are equal only if the lines are parallel. Corresponding angles are equal only if the lines are parallel. So let's now look at using these facts to find unknown angles. So these are the kind of questions that you'll need to do. Let's look at this one first. So we have a pair of parallel lines and a transversal that cuts them. We need to find what X is. So let's look at these two angles. We need to decide first which type of angles we have. So if I draw something around the angles, note I have a back to front C. These two angles are co-interior, and we learned on the previous slide that co-interior angles add to 180 degrees. So X has to be 180 minus 70. It has to be 110 degrees so that these two add to 180. So when attempting questions like this, make sure you write your reason in brackets. You don't need to write an essay about why X is 110 degrees, just one word. How do we know X is 110 degrees? And that's because the angles are co-interior. So let's look at this question here. Once again, we have a pair of parallel lines and a transversal, a line that cuts them. Let's figure out what X is. See, this question's a little more difficult because it turns out we don't have any angles that are corresponding, we don't have any angles that are co-interior or alternate. So you might be sitting there thinking, oh, what am I supposed to do? Well, if you get a question like this, just start finding the value of any angle that you know. See, just because these lines are parallel, it doesn't mean we forget what we learned on the very first slide about vertically opposite and supplementary angles. See, these two angles here are vertically opposite. Vertically opposite angles don't rely on parallel lines. It doesn't matter whether or not you have a pair of parallel lines. Vertically opposite angles are always equal. So this one here must be 115 degrees because they are vertically opposite. So I've just written my reason in brackets again, but I have abbreviated vertically opposite. So this angle has to be 115 degrees. That helps us because now we have a pair of corresponding angles. And we know that when you have parallel lines, corresponding angles are equal. So if this is 115, so too x must be 115 degrees. And once again, I put my reason in brackets. All right, let's look at this question, which is a bit harder. So once again, we don't actually have any corresponding alternate or co-interior angles given to us. However, let's just go through and find some angles that we know. Now we can find this angle here because these three angles are supplementary. They have to add to 180 degrees. So 30 plus 110 is 140. This angle here has to be 40 so that the three angles, which are supplementary, add to 180 degrees. So once again, I put my reason in brackets. So that helps us. Now that we found this angle, we can find this angle because these two angles here, they make a Z shape. They are alternate. And we know that when you have a pair of parallel lines, alternate angles are equal. So X must also be 40 degrees. And once again, I put my reasoning there in brackets. All right, let's now look at this question here. This is another hard one. We have to find the value of X. We aren't given any angles that are co-interior, corresponding, or alternate. But sometimes you can draw your own constructions. What we can do is we can draw a line here that is parallel to each of these lines. That's possible to do. So let's now find some angles that we do know. Well, we know that this angle here must be equal to that one. Why? Because they are alternate. This angle here and this angle here, they are enclosed by a Z shape. They must be equal. So we know this angle in here. We also know this angle here because they are enclosed by a C shape. Yeah, it's a back to front C, but that's okay. This angle here must be 50 degrees because these two angles are co-interior. And we know that if you have parallel lines, co-interior angles add to 180. So 180 minus 130 is 50. And that's what you should do. When you get a hard question, you should just start finding any angles you know, and you might end up finding that you can find X pretty easily. See, I know now that this whole angle in here must be 110, 60 plus 50. We also know from the first slide that angles at a point add to 360. So this whole angle is 360. This part of the angle is 110, 50 plus 60. So X must be equal to 360 minus 110, which is 250 degrees. So for that last part, I used angles at a point. Make sure you give your reasoning. That's just as important as getting the right numbers. All right, let's now look at determining whether or not lines are parallel. So on a previous slide, I said that if you have a pair of parallel lines cut by a transversal, then corresponding angles are equal, alternate angles are equal, and co-interior angles add to 180. The converse, kind of like the opposite, is also true. If you have a pair of corresponding angles that are equal, a pair of alternate angles that are equal, or a pair of co-interior angles that add to 180, then you have a pair of parallel lines. So the kind of question you'll get, a diagram like this, and you'll be asked to determine, are these lines parallel? So if you are asked, are these lines parallel, you need to look for a pair of corresponding angles that is equal, a pair of alternate angles that is equal, or a pair of co-interior angles that are supplementary. So here, these two angles are corresponding and they are equal. And this is all we need to save the reasoning. These lines are parallel as corresponding angles are equal. Because these two angles which are corresponding are also equal, this line and this line must be parallel. So let's look at this diagram here. We're going to determine whether or not these two lines are parallel. So you can't just look at them and say, oh yeah, they look about parallel. You have to have some mathematical reasoning to back you up. Now here it's a bit difficult because we're not immediately given a pair of co-interior, alternate, or corresponding angles. But again, let's just look for the size of any angles that we do know. See, it doesn't matter whether or not the lines are parallel. This angle here must be 48 degrees. The reason is they are vertically opposite. See, vertically opposite angles don't have anything to do with parallel lines. It doesn't matter in which direction this line goes, these two angles have to be equal. So because this doesn't rely on parallel lines, I know for sure this must be 48 degrees. So how does that help us determine whether or not the lines are parallel? Well, now I have two co-interior angles, but 122 plus 48 is 170. It's not 180. So if you have a pair of corresponding angles that are not equal, a pair of alternate angles that are not equal, or a pair of co-interior angles that don't add to 180, you can say that the lines are definitely not parallel. So for our final reasoning, we need not write an essay. All we need to say is because we have co-interior angles that are not supplementary, that don't add to 180 degrees, these two lines cannot be parallel. Alright, thank you so much for tuning into this video. Best of luck studying, but you'll ace it, you're a star. This has been the luckiest maths teacher in the world. Have a great day.